Hi students, this is a continuation of the last topic of optical communication. That is in the last class we have discussed about the step index fibers and graded index fiber, its basic definitions. It is its continuation. That is, we know that according to the core size, step index fibers and graded index fibers are again classified as a single mode step index fiber, multimode step index fiber, single mode graded index fiber, and multimode graded index fiber. Okay, that is another classification of single mode fibers and graded step index fiber and graded index fiber. So we will get into the details of each of these fibers, and first we will discuss about a single mode step index fiber, and its characteristics are in this, the refractive index of the core is uniform and it undergoes an abrupt change or step change at the core cladding boundary. That is, the refractive index profile has a uniform value at the core and it will be changed to another value at the cladding. And in single mode step index fiber, that is small diameter, and it is very difficult to fabricate a graded index profile in a single mode since it has a small diameter. So the single mode fibers with only step index profiles are fabricated. So single mode step index fibers have all the features of step index fiber, and in single mode fibers the core has a smaller diameter and usually it is of the order of 8 to 12 micrometers. A single mode supports only one mode or fundamental mode, and light can be launched into the single mode fiber using laser diodes, and usually we are using highly directive injection laser diodes. So this is a diagram of single mode step index fiber, and its refractive index profile is also shown, and the direction of propagation of the light is shown by the arrow mark, and here we can see that the core is represented by a small circle. That means we know that in the single mode step index fiber the core has a smaller diameter which is of the order of 8 to 12 micrometer. That is why it is represented by this small circle, and its refractive index is N1, and that is uniform at the core side, and the cladding refractive index is N2, and the cladding refractive index will be smaller than that of the core refractive index. So it is shown like a step. And in this case, single mode step index fiber, the light is injected into the fiber, or the light source is a laser diode. Some cases we are using highly directive injection laser diodes. Okay, and what is next? Next is the single mode graded index fiber. As I have said, single mode fibers have a smaller diameter. Okay, the core is very small, so it is very difficult to fabricate graded index profile in the single mode because its diameter is very small or core size is very small. So for implementing variations in the refractive index of the materials of the core is very difficult. So it is very difficult to fabricate graded index profile in single mode because it has smaller diameter. Also, the performance of the single mode graded index fiber is not very advantageous. So usually single mode fibers with only step index profiles are fabricated. Okay, so we are not interested in single mode graded index fiber fabrication and its characteristics. So next is the multimode step index fiber, and in the case of multimode step index fiber, the fiber may contain a few modes to hundreds of modes. Since it is multimode, the fiber will support the few modes to hundreds of modes for propagation along the fiber. And multimode fibers have a larger core diameter. Since it is multimode, it has a larger core diameter, so it is easier to launch optical power into the fiber. So light can be launched into the multimode fiber using light emitting diode. In the case of single mode, we are using highly directive laser diodes, but here there is no need of using costlier lasers. We can inject or we can launch light into the multimode fiber using light emitting diodes, or that is LEDs. And the core diameter in the case of multimode step index fiber is of the range of 50 to 200 micrometer, and figure shows the path of the light ray in the multimode step index fiber, and here the fiber is shown and the core is shown by a circle, and we can see that the core is have a higher diameter as compared to that of the single mode, because in the case of single mode the core is very small, but here the core is having larger diameter compared to that of the single mode fiber. So here the core diameter is of the order of 500 to 200 micrometer, and cladding is also shown, and we can see that since it is a step index fiber, the refractive index profile is same as that of the step index case. That means its refractive index will be uniform at the core side, that is it is n1, and refractive index at the cladding will be another value, that is n2, and n2 is less than n1, since cladding refractive index will be smaller compared to that of the refractive index of the core. So multimode step index fiber is shown like this. Okay, and next is before going to the next topic, we have to discuss about the disadvantages of this multimode step index fiber. And the disadvantages of the multimode fiber is that they are suffering from intermodal dispersion or intermodal distortion. That is intermodal dispersion or intermodal distortion. Both are same, and this is a major disadvantage of multimode step index fiber. Then what is intermodal dispersion or intermodal distortion? We can explain it. Suppose when an optical pulse is launched into a fiber, the optical power in the pulse is distributed over all the modes of the fiber. Since it is a multimode fiber, so the optical light when coming to the core will be distributed over all the modes of the fiber, and each of these modes that can propagate in a multimode fiber travels at a slightly different velocity. So there are different modes, so they will travel at different velocity through the fiber, and this means that modes in a given optical pulse arrive at the fiber end at a slightly different time. So the modes are propagating at different velocity, so it will reach the end of the fiber at different times. So this causes the pulse to spread out in time as it travels along the fiber. This effect is known as intermodal dispersion or internodal dispersion. So we can say that when a light source is launching a light to multimode step index fiber, it will travel through the core of the fiber. But we know that in the multimode step index case there are different modes, so light waves will travel through different path at different velocities. So at the receiving end, the modes in a given optical pulse arrive at the receiving end at a different time, and this causes the pulse to spread out in time as it travels along the fiber, and this effect is known as intermodal dispersion or intermodal distortion. And this effect can be reduced by using graded index profile in a fiber core. Okay, so the intermodal dispersion can be reduced by implementing a graded index profile in the multimode fiber. Also, there is another disadvantage, that is Indus symbol interference. What is this symbol interference? We know that in the multimode step index fiber there is intermodal distortion, and due to that intermodal distortion, the width of the received pulse becomes larger than the time allowed to the pulse at the time of transmission. This spreading of the pulse causes the interference of the adjacent bits, and this effect is known as a Indus symbol interference. So in the case of multimode step index fiber, due to the intermodal dispersion, the width of the pulse become larger than the time allowed to the pulse at the time of transmission, and the spreading of the pulse causes interference with the adjacent bits, causing Indus symbol interference. So these two are the major disadvantages of the multimode step index fiber, and this defect can be reduced by implementing a graded index profile in a multimode step index fiber. That means instead of using step index profile, we are using graded index profile. So next is multimode graded index fiber. And in this fiber, the core diameter varies between 50 to 100 micrometer. That means core diameter is large compared to that of the single mode fiber. Because of the larger dimension, it is easier to launch power from an optical source to multimode graded Indus fiber. For example, a diffuse source like a light emitting diode can be used to launch optical power to a multimode fiber. And the performance of the multimode graded Indus fiber is usually superior to that of a multimode step index fiber, because in multimode step index fiber, intermodal dispersion and intersymbol interference is present, and the intermodal dispersion can be significantly reduced by making use of the graded Indus profile. And this grading in the refractive index of the fiber core helps the oblique rays passing to the higher order modes to travel faster and make up the delay caused by various modes. So we are saying that we can eliminate or we can reduce the intermodal dispersion in the case of multimodal step index fiber by implementing graded Indus profile to that. That means how it is possible? We are introducing a graded Indus profile at the core side. So the grading in the refractive index of the fiber core helps the oblique rays corresponding to the higher order modes to travel faster and make up the delay caused by various modes. Okay, you got the idea? We know that in multimode fiber, the light rays travels in different modes. So higher order modes will travel at a different velocity than that of the lower order modes. So it is received at the receiving end at a different time. So there will be spreading occur. And when we are using graded Indus profile, the refractive index of the core will be varying from the center of the core to the interface between these two core cladding interfaces. So when we are using grading in the refractive index profile, the higher order mode rays, that is they are traveling in an oblique way, and this change in the refractive index will help that oblique rays to travel faster and make up the delay caused by various modes. Okay, and figure shows the path of the light ray in the multimode graded Indus fiber, and we can see that since it is a multimode fiber, its core diameter is high. It is of the order of 50 to 100 micrometer, and there is cladding and cladding refractive index is N2, and we cannot say a single value for the core refractive index, because we know that since it is a graded Indus fiber, its refractive index will be varying. Refractive index will be varying, and it is highest at the point the central point of the core, and it will be changing. It will be decreasing towards the core cladding interface. And here it is shown that it will be changed in a parabolic manner from the center to the core cladding interface. Okay. And the next, we can write the equation for a multimode graded index fiber refractive index value, and we have already discussed in the previous class that it can be written as multimode graded Indus fiber refractive index can be written as n of r. It is written as a function of r. What is r? R is the radius of the core. Okay, so when the radius of the core is changing, refractive index value will be changing. So we can be written it as a function of radius. That means refractive index profile n of r is equal to n1 into 1 minus 2 into delta r by a raised to alpha whole raised to 1 by 2, and this is the value of the refractive index when r is less than a. That means when the radius is less than that means the radius is less than the radius of the core a. And the next n2 is the refractive index profile at the cladding. That means n2 is equal to n1 into 1 minus 2 into delta raised to 1 by 2, where r greater than or equal to a. This is the equation for refractive index profile in the case of multimode graded index fiber, and based on that equation we can see that alpha is a, there is a, based on the equation there is a term alpha. What is alpha? Alpha is a profile parameter, and delta is the relative refractive index difference. Okay, and in this figure the profile parameter alpha determines the shape of the core's profile. As the value of the alpha increases, the shape of the core's profile changes from the triangular shape to step, as shown in the figure. That means whenever alpha is increasing, the shape of the core profile will be changing, and whenever alpha equal to 1, then the refractive index of the core will be like a triangle, and there is no change for the refractive index of the cladding. When alpha is equal to 2, that means profile parameter is increasing, then the refractive index of the core will take a look of a parabola, and whenever it is increasing and when it become infinity, the core refractive index will be exactly same as that of the step index fiber. That means it will change from graded index fiber to step index fiber. Okay, and next is the light propagation in multimode graded index optical fiber. Okay, we know that in the case of a single optical fiber, what is an optical fiber? Optical fiber is an dielectric waveguide, and consists of a core and cladding, and also there are other protective covers, and we are interested only in core and cladding. And usually in the optical fiber, it is a dielectric medium, and in that information is transmitted through core. Okay, that means the core is made up of glass or plastic, and information is transmitted through that glass or plastic fiber, and that information will be in the form of light. That is, it is called light optic communication. Okay, and the light is propagated through the core, and it will not propagate through the cladding. Okay, usually the light will be confined to the core portion only by the phenomena of total internal reflection. We have studied about the total internal reflection. Okay, and in the case of multimode graded index an optical fiber, the rays propagating through the graded index fibers are indicated with the help of a curved ray path. And here this figure, second figure, shows the propagation of the light in the graded index fiber, and here this is the second figure shows the core section only, and for analyzing it completely, I am representing the core section only, and in this core we are drawing different lines. So the rays propagating through the graded index fibers are indicated with the help of curved ray path, as shown in the figure. In order to understand the propagation of the light rays through the graded index fiber, let us consider that core consisting of several coaxial cylinder layers, and these cylinder layers have a slightly different refractive index. So we are representing the core by different cylinder layers. So we know that core is the central cylinder. Okay, and for analytical purposes, how the rays are traveling through the core, we are representing the core by different cylinder layers. So in this section we can represent it as by dividing into different lines. Okay, and each of these lines represent different refractive indices. Okay, and we know that the refractive index will be high at the center of the core. That means the inner cylinder will have a higher refractive index. Okay, the inner portion of the core have a higher refractive index, and this refractive index will decrease progressively in the outer cylinder layers. Okay, I think you can view the idea, and then only you can understand the concept. And we can find and the representation is like that. and the cylinder layers may be assumed to have constant refractive index. That means we are representing the core by different cylinder layers, and that means one cylinder, and out of that cylinder there is another, and out of that another cylinder and another cylinder. So it will be like a different circles, and we are representing a ray is traveling to that core, okay, and then we are analyzing what happened to that ray whenever it enters into that core. So for that purpose we are representing the core as different layers, and these layers will be represented by the different lines, okay, that is shown in this figure. And we know that at the center the refractive index will be high, and whenever it goes to upwards or it goes to the core cladding interface, the layer will be having lower refractive index, okay. And also for the purpose of simplicity, for simplicity purposes, we are assuming that each of the cylinder layers have a constant refractive index, okay. So the central cylinder have a refractive index which is the highest refractive index, and the cylinder next to that of central cylinder will be having a refractive index which is slightly less than that of the central cylinder, okay. So whenever the meridional ray travels from the central region towards the core cladding interface, it travels multiple refractions at successive interfaces or high to low refractive indices of the imaginary cylinder layers. So before going to the details, first of all you should understand what is a meridional ray. Meridional ray is a ray which lies in the plane containing the axis of symmetry of the fiber. So you know that there is a core. When you are considering the transverse section, there is a core at this center, and out of that there is a cladding, and at the core the central line, there is a central line, and meridional ray is a ray which lies in the plane containing the axis of symmetry of the fiber, okay. So when we are considering a plane that contains the axis of symmetry, then meridional ray will be lying in that plane, okay. You got the idea? That means meridional ray is a ray that lies in the plane containing the axis of symmetry of the fiber, okay. So when the meridional ray, that meridional ray will lie in the plane that containing the axis of symmetry. So when the meridional ray travels from the central region towards the core cladding interface, it suffers multiple refractions at the successive interfaces of the high to low refractive index of the imaginary cylinder layers. We are assuming there are different cylinder layers inside the core, and each of these cylinder layers have a constant refractive index. When the meridional ray passes from one cylinder layer to other cylinder layer, that meridional ray will undergoes refractions, okay. Because of that refractions, the ray will be changing its path. So as the ray travels from the denser to rarer medium at each interface, the angle of incidence at successive interfaces goes on increasing, and at a certain layer the condition of the total internal reflection will occur, okay. When you can see it from this figure that when the ray is inciding on a particular layer, that incident ray will be refracted, so its path will be changing so it has got some angle of incidence and some angle of refraction, and next that refracted ray will be incidenting at a next layer, so it is again refracted. So this refraction takes place in each and every layer where there is slightly different refractive index of the layers. So the light ray path will be changed, and whenever the light ray travels continuously, at some point of the layer it will undergo total internal reflection, okay. So when the angle of incidence at a particular interface is greater than the critical angle, the ray gets totally internally reflected and starts traveling back towards the core axis. Okay. So when the angle of incidence of this ray is greater than that of the critical angle, it will be totally internally reflected back. So since the ray travels in, in such a path, its path will be like a curved one. Okay, it is shown in this figure. Okay, the incident ray making different angles with the axis of graded index fiber is thus reflected from different radial distances from the axis. So the overall effect will be like this. So the path of the light ray in a graded index fiber will look like sinusoids because of total internal reflection for different rays occurring at different radial distances. And this is the mechanism behind the light propagation in multimode graded index fiber. I think you understood the concept. If you have any doubt, you can ask me. This is all about the classification of the fibers, and we have discussed about the single mode fibers, multimode fibers, step indexed fibers, graded index fibers, and also single mode step indexed fiber, single mode graded index fiber, multimode step index fiber, and multimode graded index fiber. This is all about this session, and next we will meet with another topic. Okay, bye.